that would essentially perform exploratory testing automatically. And the idea would be that it can continue learning and adapting to new situations to kind of make it faster for a tester in particular to gain feedback from an application that wouldn't have to necessarily be something that they do repeatedly. So it's automating out kind of the exploratory testing process. Now, I just want to get some more demographics here. Everybody that just came in, are you developers or testers? Developers? Okay.
Were you hoping for testers?
Sorry?
Were you hoping for some testers?
Oh, we have some testers. We have some developers. So this is good. Is anybody here familiar with the Selenium for browser automation?
Tried Selenium, tried Watton. Didn't really like either of them too much.
Okay. So what Selenium does is it allows us to interact with the browser as if it was a person interacting with it. And then what, is anybody familiar with approval tests? Yes.
I could use a refresher. Assume I know that.
Okay, so
anyone familiar with theory tests?
okay, so unit testing. You guys do unit testing in your organizations?
I just moved jobs, and the other place was really waterfall-y and full.
Yeah. Does your new organization use unit tests?
Yeah, it seems intermittently, but I've only went there 2 days, and then I came here, so I haven't had a lot of chance to see it.
Okay, so I'm going to go ahead and start with kind of a little overview of doing things with unit tests and approval tests, and then just to kind of build a foundation for us here. Then I'll kind of show some Selenium stuff, then I'll do a little intro to a very basic artificial intelligence, and then we'll start building an automation to look at it. I'm sorry for testers because it is very code heavy, but it should be readable and understandable, so I think it'd be okay. First of all, what we have here is I put together a simple ASP.NET for Webpage, and so it will render HTML out. It has some jQuery stuff going on, but this is the basic CSS3 template for it. You can go to the About page, you can go to the Contact page. So this is kind of a very basic interaction that can happen with this site. So this is kind of like their default template, so it comes created this way. What's happening behind the scenes is, let's see if we can get code here. So this is using a model view controller system. So if you're familiar with Ruby or PHP, basically Microsoft's version of model view controller allows you to interact with the database using the model objects, which I'm not using any here. Then the controllers route information to a page, and then they render HTML, which can be displayed to whatever's consuming it. So in this case, we have a controller. We have an index action, an about action, and a contact action. This is all code that runs before it displays a page that uses the views that have HTML and then some code generation in the HTML to gain information back to display it to the users. So that's kind of what's happening here. So if we run through it real quick, this viewbag.message equals modify this template. That viewbag.message is going to get rendered inside the H2, and so if I run it, then the modify this template to, so if I modify that in the code, then it'll modify it, and then the HTML will still display the same. So it's a view for the data coming back from the controller. So is that understandable? Okay, so as a unit tester, as somebody who's doing unit tests, you can either go in and verify that the viewbag is being used properly and check what's inside the view bag at the moment. So let's look at that real quick. Test. And so you can just verify that what's happening in the view isn't really happening. What's happening in the view is you can't test what's happening in the view. You can only test what's happening in the controller with the traditional methods of testing. So the reason I tend to use unit tests is so that I can see exactly what comes back from the compilation of the model view and controller. So that's essentially what we're going for here. Controller space home controller, and then we can say controller dot index. So this will return a action result for the index action. And so that's kind of my the AAA kind of arrange, assert, or arrange, act, and assert, which is I'm going to assert r equal, and then it would be some information. So action dot. This a view result action dot view bag dot, and so this is message, and then comma, and then now you have a string and you can compare them. So in this case I can just copy that string, and to get a failing test here, yeah, so we can just say view data, and then here, okay, this is like a really fast overview of unit testing and MVC, just to get a basis of what's going on. So in our test explorer we have a failing test, and we've tested whether or not they're equal. So the assertion failed, modify the template to start. So does that make sense why it's failing? Because I'm just comparing it to an empty string. So if I now paste in the value that was set earlier, we can see that in the test explorer it's passing now. So because they're equal. So that's essentially unit testing the view bag. So that doesn't give us a lot of information about what's happening in the view, because if I do that, if I do this, if I go into the views, I go into my index and put an X after the paragraph here and run the test, nothing is going to tell me that that X has been typed in there. So we don't know if our HTML has changed or anything along those lines. So what you can use is is approval tests to arrange a test like this. So these are home tests arranged in approvals. So basically what approval test is allowing us to do here is to create a controller, set a port, and then I currently have it running on this 1, 2, 3, 4, 5 in the solution, if anybody's interested in that. Oops. So web, and then just to prove it right here, 1, 2, 3, 4, 5. This is setting a specific port. So when I run this, and you can actually use something called Cassini to put this in a continuous integration server. So it essentially runs on that port right now in the local web server. So moving forward, what we can do here in this, in our home tests, is I can say run this test, and what it'll do is give me a compare view using code compare to see all the HTML that was rendered from that page. So now not only can I test what's inside the view bag, but I can also test what gets rendered out in the end. So now I can verify everything up until the point of display. So I can say anytime I look at this page initially, I know exactly what it's going to look like every time while I'm developing. I'll never have to test that again, right? The problem now is the full stack, which is database, web server, and all the way through to the user. Because typically when you're doing basic unit testing, you're testing with mocks and you're omitting the web server and the database. So once you're forced to kind of do a full stack test, you want to include all of those, and you want your database to have test data, and you want to be able to automatically reset your database so you can go all the way down. But even then, all you're able to do with approval tests is test the page at that state, unless you're using Selenium. So so I can approve this, and I'll just show this kind of the pass and fail cycle for these. Is if you modify something that breaks a piece of code somewhere else that destroys your full stack, then you're going to see the tests come back. So let's see, test home index, if I run that again, comes back as passing. So now I can go into the home controller, and I can put an X there, and it will show me exactly where that showed up. So now it's actually highlighting what broke, right? And so it'll tell me every time, and then I can reapprove it and continue forward, or I can go in and fix the problem. So, oops,
That code compare view, that's a feature of the approvals, right?
that is, so you can use a number of different comparison tools, and approvals will kind of hook right into it. So if you have SVN has its own compare tool, and any number of other ones. This one integrates directly into Visual Studio, which I like, and so that's why I use it. But it's a little bit buggy when you have hundreds of tests running. So now we can, like I said, verify, and so now I can show you modifying the view. So if I just put an X in here, this would kind of, something like this would break display, you know. It's outside of the tags, it wouldn't look right, and so on. And so I can actually go back into the home tests and run that again, and now see where the break happened. And then what you can do is then check the view and what it would return, and then see that it's not coming from the controller, it's coming from the actual view, and you can go in and fix the view. Or, for example, just somebody typed something in and they didn't expect it to break something, and then it would show up, and so on. So it's extraordinarily helpful, and I would suggest learning it. Its approval test is out there for Java, for Ruby, for just about everything out there. Llewellyn was in here a minute ago, and he is kind of heading up that open source project. So if you ever want to pair with him and stuff like that, he does take to interactions like that. So he ports it to everything he can. So it's really good. In our case here, now moving on to the artificial intelligence portion of it, actually not yet. So now I'm using Selenium. So this test here is a test to essentially navigate the browser to a certain point, and then I want to approve the page after the browser has loaded. And I just want to approve something that has an element so find element by class name. Inside the stuff here, let's see. So we have classes on we have display properties for things that we show inside the CSHTML. So for our index view, for example, we have a class for title, and then round. So our class round is located here. And so it's an ordered list. And so I say I just wanted to verify everything in the order list after I load the page. What this full stack test will do is actually allow us to run on the web server and have it start up a browser, check what's on the browser, and then give me a compare for that. So that is kind of the direction we go. And so currently in our offices, what we do is we have a number of automated tests. All testers on the team are programmers, all programmers on the team are testers, and so this is how we do full stack testing. And so a big problem and a big time sink for us is doing, not automating, just doing exploratory testing. So we're trying to think of ways of how can we do most of the exploratory testing that we would normally do by automating it. And so there are typically things that people do that will try and fill out special characters and things like that. So like all the initial things that you think about by doing exploratory testing that doesn't typically end up in your unit, or might not necessarily end up in your unit tests. Stuff that comes back from posts is really hard to do a full stack test for and things like that. So currently what we do for posts is we actually mock out the database, and then we make sure values are saved and filtered out properly and things like that. So in this situation, you can actually have it run through the application. From within the code, you can reset the database so that it has the initial set of data. Then you can have it run through all of the actions that would, like clicking on things, entering data, interacting with JavaScript. And so ultimately, you get this kind of automated way of working your way through things. So right now, we can generate tests based around the idea that we feed it a CSV file with all the test data that we want to add, and then it will attempt to do that testing. So our next kind of thought is, well, where do we go when we're trying to single out behaviors in developers that, things that they get wrong all the time, things that we want to test first, and things like that. So now that you've kind of seen how we're going to do it, I can go into, I'm just going to look up PEAS, artificial intelligence. Okay, so there's a wiki on this, and so what PEAS stands for is performance, environment, actuators, and sensors. And so this is how you set up a really basic, this is kind of the first month of your first artificial intelligence in a master's course, essentially. And they kind of go over this, and they have this this puzzle called the Wumpus world, and it's the typical kind of example they give when they're working through this. So first, we kind of need to run through the definitions of all these terms. So P stands for performance, as a function that measures the quality of the actions the agent did. So you're not going to get true intelligence from this approach, but you can get machine learning out of it. And so the idea would be to have a strong way of doing min-maxing and evaluating the performance of something. So if you don't have a way of actually telling the computer how it's performing, then it won't be able to know. So therein lies the problem. That's where you still need a human, is to kind of define the situations where you can actually say there is success, right? So the next thing would be to move on to environment. And so environment is actually divided up into a number of other categories. And so I'll just run through this real quick. So it's the essentially playpen in which the agent acts. So if we kind of look at our intelligence, we are on this world, and we have the ability to go in space, and we have the ability to get different careers and learn different things and so on and so forth. So for an agent that was to be an exploratory tester, you kind of need to boil it down to whether the environment's fully observable or partially observable. And so that means that, can you see the entire situation? Can it read through all the code and understand everything that's happening, or is the environment dynamic? Is it and closed off to the decision maker? Can you find out whether or not you can score this information? The next thing is deterministic versus stochastic, non-deterministic. And so it's whether or not you're dealing with probabilities. And so you kind of want to define whether or not you're just getting percentages back or you're getting actual strong values. Episodic versus sequential, like can you use past experience to identify whether or not things can be scored properly? Or is it sequential where you continue operating the world no matter how bad you've made it, and you don't get any do-overs kind of thing. And then static versus dynamic, whether or not the world it operates in can grow or contract. And then discrete versus continuous, and that's kind of along the same lines. And then single agent or multi-agent, meaning that are there multiple operating artificial intelligences operating in this environment, and can they communicate and things along those lines. So I can go into those a little bit more detail later. So now, finally, actuators are the set of devices that the agent can perform actions for a computer. It can be a printer or a screen or a mechanical robot, something along those lines. Sensors can allow the agent to collect information, to perceive information about its world. And so kind of just to run through these real quick with the Wumpus world example, basically its performance measure is whether or not it can kill a monster. The agent, being a person, can go around this world and kill a monster and collect the treasure without being attacked back. And so, let's see, they have, I think, a picture of it somewhere in here, but the actual screen is too small, it's not showing pictures for us. So there's a scoring system for Wumpus World that is based on whether or not it can complete those actions. Then the environment is a grid that it can walk through. The actuators that the agent can take is to move forward, turn left, turn right, pick up gold, fire arrow, and exit cave. And then the sensors have 5 basic sensors. There's stench when there's a Wumpus in an adjacent space. A breeze where there's a pit in an adjacent space, so if you run on the pit, you die. Glitter where there's gold in an adjacent space. A bump when an agent has hit the wall, and a scream when the Wumpus has been killed. And so the way you kind of can organize this is that's kind of how their environment is defined for the Wumpus world. So in our situation, what we can do is essentially define that P's example for a agent that would play in a website. So for the performance measure, we would just say for our first iteration of kind of this bot is to say don't crash, right? The website doesn't, or the website finds crashes, right? Finds situations where the application will crash. Then you can further define it to say finds situations where the application behaves differently than expected, right? So in those two situations, we can kind of clearly define what we need, except the second one is so loosely defined that we actually need to find ways to better define it. And that's kind of where heuristics come into play. And I can, you look like you had a question.
So if your agent doesn't find places where it crap, like the absence of evidence isn't evidence that...
Okay, so yeah,
it's not proof that it works.
Right.
It's we've tried stuff that shows that these examples work. That you
yeah.
never know that the stuff you didn't try works.
Mm-hmm.
Ever.
So that's kind of where we define the environment, and we can say that the environment is only it's not fully observable. It's only partially observable. That means that there is something out there that could happen that would show us that there's this situation where it's a problem. So I'm going to skip environment for now because we can kind of more clearly define it over time as a group. And So the actuators. So how do we, from what we've seen just now, how do we interact with the pages? How can we click on something? It's just using Selenium, right? So Selenium allows us to interact with the page from the perspective of the user. So now we actually have a way to use actuators, right? And then, so that means that you can have like clicking, navigating, reading, etc., right? And then with sensors, essentially with a combination of Selenium and approval tests, we can verify that our heuristics are correct, and then from the perspective of the agent, it can just use Selenium to actually read the page, right? So we know that we can test the reading.
Have you talked about theory tests?
No. Do you want to go over real quick?
Do I have to just
Go ahead.
give a little context? So a lot of unit testing is given A, expect B, right? And the issue with that is there's a human involved that knows A and knows B. So theory-based testing is given A, expect a theory. And the nice thing about that is it doesn't matter what A is, right? The theory is consistent. So the first thing he wrote is a nice theory test. Given that we do something on the website does not crash, right? And it doesn't matter what you do on the website, you have that theory, it shouldn't have crashed, right? Another, I'm just going to give a couple of different ways of doing theory testing. A nice way also is inverse theories. So given that the Wumpus moves in whatever direction, when I move the reverse of it, I should be on the original square, right? So an inverse theory. Another example of that is if I have like an ORM, if I take an object and put it into the database and then retrieve it from the database, it should be the same object that went into the database, right? So those kind of tests, you just need something that generates objects, and you can throw them in and test it. You don't need to know. And the advantage of a theory test is you can put a generator in front of it and just start testing a large amount of cases, right? The expected behavior test that he wrote is also a theory test, but it's, when he said loosely defined, you need some sort of model that shows that. Now, one way could be, right, that you have the Wumpus game on, as a, not as a website, but as like a WinForm app. And you make it so your actuators go both to the WinForm app and the website, and now you can just randomly start testing things and say, hey, is there ever a time where these two things behave differently? Because you reduce, once you have that theory test, then you can put a generator in front of it. Does that make sense?
And then also the kind of ideas that are represented here, and when we loosely define these things, is that not only will the generator kind of give you new information to test with, but it'll also, the idea would be to eventually find patterns in the developers of things that they typically make mistakes in, and then kind of drill down to that situation first, so that you can quickly find in certain situations.
So another common is like the dead link test, right? Like there are programs that will scan your website and say, are any of my links dead? That's a theory test based on commonality of programmers have a tendency to make links that no longer exist.
Yeah, and so the idea now is to develop new commonalities over time, right? That's where the learning portion of it comes in. So just for an example, a brief description of the Wumpus world, you have the player here, and that's the start. You have breezes around pits, and so basically the world is partially observable here, so he can only see these squares, and so he knows there's a stench here, a breeze here, nothing here, or I don't even think he can see this square. It's only adjacent tiles he can see, right? So he can say, I'm going to walk here, but now that he has the breeze, it's only his own tile. So now that he has the breeze, he knows that if he walks up here or here, there will be a pit, right? So he may want to go back and try up higher. So now he has the stench. So basically, he has to guess between these three tiles which one is going to be the best one to go to. So, for example, he may just default to moving right in unknown situations, and then he would go right again and then potentially die. So he could go right and then up, and then there's nothing in there, so he can move in any direction and be safe. And so you can move up again, and then there's, you know, gold there. So I think there's supposed to be glitter here to signify that there's gold somewhere. But that's the basic idea. Is as you move through this unknown world, you kind of discover things about it, and then you're supposed to then learn from your past experiences. And so what they do here is they allow the agent to start over and over again to be able to navigate through this, you know, terrible situation, right? So kind of moving back to our agent here, what we could do is write a little bit of JavaScript to essentially let's see here. Okay, so we have this JavaScript 1 file here, and we can do some initial jQuery. And in here, we can essentially do a selector on this class. So okay, so essentially I'm replacing everything within the tag that has the round class with hello world. And jQuery is also a very useful tool if you're working in HTML. I highly recommend using jQuery. And so in this situation here, we expect all of this to kind of be replaced after running through it. And potentially, you know, we could use Selenium to find out if that operates correctly. And so we also would want some other things that can create a crash over time and things like that. So let's see here, index, add section, oops. Okay, and then I'm just going to say the JavaScript 1 guy here, and so if we run this, and wait, could not copy because we have some situation here. Chrome driver. So since I didn't allow it to finish the test earlier, Chrome driver doesn't continue working. Okay, so Chrome driver being the way that Selenium hooks into Chrome. So you'll notice that we didn't even see kind of when it's getting replaced. So right now, what are our unit tests going to say there? Our unit test should still pass because we have it's JavaScript. It's happening after the page is loaded, but not before we see it, right? So it's kind of an interesting little situation. So that's kind of like setting the scene a little bit more for us. Let's see, stop that. All right, so let's go back to defining our environment. All right, so in our kind of environment, is a web page fully observable or partially observable? And I should say a website, right? That's kind of what we're testing here, is a whole website. So does anybody know if it's fully or partially observable? Yeah, well, it could be if you could read through all the pages initially and feed it to the agent. But in our case, it's going to be partially observable, right? Because you can't click through and you have a database interacting with the web page unless it's dynamic, right? And so that means that it would only ever be partially observable unless you could do calculations to find out every possible combination of situations that come back from the code, right? And then therefore the code for the agent would be as sophisticated as the code for the actual project, and then you'll be testing for the rest of your life. So, part. So we're going to say it's partially observable, right? So that means that we can now assume that our agent's going to have to determine what to do in that situation, right? And so if it's deterministic or non-deterministic. So in our situation, we do have, I mean, in code in general, we're dealing with deterministic kind of values coming back. We're always going to render the page out if we committed the same operations and the database was the same. If everything was the same, initially we have a deterministic outcome, right? So there are situations, though, where you have multi-threading and you have asynchronous jQuery running around in the background. You have lag times on the network. So I think it's better to define this situation as non-deterministic from the perspective of the agent, because it's everything is so dynamic that you wouldn't be able to mimic certain things like lag times on the network. So we're in this case, we're non-deterministic. Okay, so moving down, episodic versus sequential. So you can always return to a home page, right? And you should be able to always reset the database and rerun through the database and cause it to, you should be able to cause everything to reset and come back through and operate on the same situation again. So in that case, we can call it episodic, right? Because our actions are not permanent unless we can't reset the database. We can't return the status of the application back to its original state. So we can say episodic. Discrete versus continuous. So the page could potentially generate a website could potentially generate new pages based on data in the database, right? You have multiple details view for different things, and so the whole thing is kind of continuous. You're not going to have a discrete set of things that you have to run to. So single agent versus multi-agent. So is Facebook single agent or multi-agent when you're operating against it? Yeah, it's a heavily multi-agent system, right? So somebody can go in and change something that
and the more stochastic it gets too, then with more agents in there too.
Yeah, so you can say multi-agent. So you could potentially create a system for testing situations where a number of agents are operating against it and record all their actions and figure out what had happened in a certain situation that blew something up. You could potentially create test situations where you have a number of different things coming out. So that's it for our definition. So we're kind of ready to start writing something, and we can quickly, with the amount of time left, hopefully create a random agent. And then I can also go over heuristics. So if we kind of like knew all these tools from the beginning, I could have gone all the way through the talk. So a heuristic in artificial intelligence is kind of a set of code that specially determines situations that that you can't kind of do general code for. So a good example for this is that developers typically don't account for putting semicolons in a form that they're submitting with a post or something. So it would be something that you could put in a heuristic for, and then that heuristic can get scored up or down based on how often that happens with certain developers. And then you can also do comparisons against your code repository to find out whether that developer has worked on that code file recently, and you can score it higher based on the person that has modified the code, and then eventually you would read back information or cause it to crash based on that same situation. That would be the first thing you test against. And so the agent would be designed to quickly root out issues that might come up that have more complex situations even than traditional exploratory testing. So in here, there are a couple things happening. We have the approval tests. So the arrange, this is kind of an act, and this is kind of an assert, right? And so we're navigating to the URL, and we are kind of finding that class and then determining what the text is. So this test now should give us different results, hopefully. So yeah, it's deleting what was there before, even though, because you're now running in the full stack. So, and that's actually a race condition, right? Which one comes back first? So say, for example, we want to have the page verified as soon as it loads, and then verified again once it's finished loading. So let's say here, so we can now create kind of a new class. And then we can generate him, and then we can say so we can tell the agent to kind of make its decision on what to do, and then do that, right? And so kind of what we can do is say agent.act, and now we can kind of verify what's happening inside the agent. So now you can say, for example, let's see, return empty string. So now you can essentially arrange the agent, and then the agent can, for example, navigate to our location, and we can say agent.act is in there already. And then, so now this is saying go to that location, and then finally we can return kind of our sensor result. And our sensor result would just be more, a little bit better, the full page, right? So we can say split declaration, control D, factor, introduce fields, driver. Okay, so now it initializes it in the act, and this probably actually should just be initialized inside the constructor, maybe. So, whoops. Okay, so the okay, so right now this agent is random, and it's not even random. It's kind of only going to a single page, right? And it's now acting against the world, and with those actions against the world, we can actually verify in approval tests the current session, the current sensor data, right? So in here now, we can run that again, and it's kind of refactored in such a way that it should run the same way it did before and kind of give us the hello world back. As long as it's probably, oops. Again, that's Selenium kind of bugging out a little bit. Although typically you'll leave the WebDriver in a continuous integration server, you leave the WebDriver open, and then it does all its operations and closes it properly. But I keep stopping everything from happening properly. So little bit what's going on. So we know that that div has kind of the hello world in there now. And so, but we're not really telling it to do anything special. So what we could do potentially in the act portion of the agent, and just to get things set up, is to get all links that are currently on the page and then navigate to them individually if they're still in the local host kind of thing. So you can say driver dot find elements by tag name, and then you can say A, and then that should get us a list of those elements, right, for each. And hopefully we can say and so we kind of want to find out if it's visible. No, I guess we don't have visible. So, sorry?
Display testing.
Oh, maybe it's, yeah, display, cool. So we can find out whether or not it's currently being displayed. So can the human interact with it, right, from this point? So we kind of ignore hidden links. It's just kind of like a nice thing to put in there. And let's see. So we kind of want Selenium, get link destination. Links destination. Testing all links. Oh. Not quite. Alright, so we'll fake it for now. So we can find, for example, item dot text, and then maybe we can just say link name list dot add. And then field list string. And then enter initialize field for constructor. Okay, so this will add them to a list, and then we can kind of spit this out from the agent just to kind of see us getting that information from the thing. So let's see. Aggregate x, y, x plus y. And so we kind of can see that inside the test come back from the agent. And, oh, wrong thing. Let's run that. Yeah, it's a little bit of a pain. Got to make a better way for doing that.
Does it operate similarly on other operating systems?
I mean, it's a separate executable. So what's happening right there is the test runner's running, and then it's not getting to the end of the test to dismantle it. So the proper way for me to have done that is to create the test class and place it inside the deconstruct of the test class. So that's all that's happening there. So although I might have just done it again. Well, we're almost done anyway. Man, it's unfortunate.
right now you're doing link detection, right?
Yeah, that's essentially kind of the simplest thing we can build right now.
What are
But
some of the theories that you have come across in these experiments?
well, so you know, test obsessed kind of their whole thing. They have
So that's the crashing theory.
yeah, just crashing it using various inputs and things like that. There is the idea that there needs to be a way to define kind of a happy path for the system, and then once that's defined, it can take as many tangents as it possibly can to.
Have you done like performance theories on there? Like if you hit it with 5 agents, does it?
Yeah, so that's the thing is that would be a good addition for it is to approach it with the multi-agent kind of situation. And there's also other scoring techniques that can be used in heuristics. That's what I was talking about earlier.
And have you done it with modeling?
No, I mean not yet. I mean this is at the very basic level right now, but that's kind of what we're thinking about at the moment.
The idea of tailoring the agent to who wrote the last bit of code is really interesting.
Yeah, so I've been thinking a lot about kind of reporting performance back
This
to.
guy always does this.
Yeah, I mean, yeah, I make the same mistakes.
Yeah, so if somebody typically makes the same mistakes, and then you can detect from the code repository whether or not they have modified a chunk of code related to something, and you can define that, then it would be very easy to go in and say, hey, this has a strong correlation, let's test that for that first. And that would essentially, you know, you'd be able to fill up all the bug reports and everything like that, and then, you know, other testers can go on testing something more significant. Yeah.
So there was a guy who did React, which is a NoSQL database, and modeled it in Erlang using a hash map, and would literally just made his actuators hit the hash map in React, and then just ran them thousands of times until he found concurrency issues.
Yeah.
Like, hey, Erlang, which doesn't have concurrency issues, is performing different results than when I do it against React. And
That's
then,
good, I like that.
like, he was able to take what he found and then reduce it a little bit, right? So these 15 steps give me concurrency issues, you know, went out 10,000 times. What about these 14 steps?
Yeah.
Okay, and get it down to sort of, okay, at 8 steps, this seems to be the issue. We used it for concurrency detection, which is something that is otherwise almost impossible to detect or unit test.
Yeah.
Right? Because
That's really difficult. Yeah. So yeah, aside from logging, but that's also another thing is that you could potentially have the agent itself paying attention to the logs and figuring out when concurrency issues arise.
Have you explored it all with like, because most of your stuff is going directly through Selenium to the website.
Yeah.
You could also just make like a direct API to the same website and
Yeah.
say, when I go through the website, is it the same as when I go through
Yeah.
the interface or the REST call?
Yeah, so that is another thing you can do. And that's kind of the difference currently in our office with our Selenium tests and our MVC approvals. So currently, you know, the MVC approval will come up and none of the JavaScript runs. And then post JavaScript run, we have a new verification that needs to happen. So, yeah, those are kind of the next steps that we're taking and want to take and moving forward with. So, it's interesting stuff. But,
So what happens when programmers become testers?
well, testers and programmers, you know, they should be one and the same in my opinion. And it's the whole thing is automating is really important. You know, if you're ever doing anything as a programmer over and over again, which I see endlessly, is that they should automate that. You know, and there were a lot of similar sets of code that we were writing almost over and over again, and so we. For new projects and sometimes for existing projects, we generate whole portions of it because it's based off of those same things, and we actually generate the tests alongside those. And so it's a nice, clean kind of slate to work from and then customize towards.
Yeah, it's interesting because I've usually had a manual tester and an automated tester
Yeah.
on my team, so that the manual tester, is designing the test cases for the new work in this sprint,
Yeah.
testing those things, and then the automator is automating as much of those as he can, and deciding, kind of more happy that, which things to automate and leave in place behind for the unit tests that run like or whatever, builds.
So, and then that's the kind of thing is that maybe you just need a person to define what the expected outcome is from operating against the site, and then have an agent essentially figure out all the tangents and work through it. And that's kind of what I'm approaching here, is because the business people are going to create some sort of metadata around how something should operate, and then the developers will code it and make sure that that works, and then there are always kind of these leaks of where things should have been or how things should operate. So I think that's my approach here. But I mean, this is kind of in really early stages, and
Can you get, I guess what I'm trying to figure out in my model is, can I get if all the tests are done as programming tests, can I get that done fast enough to get out this sprint? It seems like that's kind of, I think, essentially why we have a manual and an automated is two reasons. One is the manual can slam through these test cases, create and review with the team,
Yeah.
the test case is done, real fast turnaround, within the sprint. By the end of the sprint, hopefully he's gotten to the last one and got them done.
Mhm.
Whereas the automation seems, to write those seems to be a smaller subset of that we leave in place.
Yeah.
And then.
So, and there was another kind of thing that I was thinking of, is a heuristic that you could create is to data mine unit tests and see what the developers that are actually thinking are going to happen to their code, and then that would give some sort of indication to how to move forward. And even data mine code for if you can find certain situations where names repeat and stuff like that. Like, there are all these little heuristics that you could come up with to kind of attack these problems. And so, I mean, it eventually could be that people are just sitting there thinking of new ways to approach this rather than thinking of the same old ways to approach a different set of metadata, right? And that would be kind of cool to just turn this thing on and say, actually give it the metadata for the project before the sprint, and then allow it to figure out what's passing and failing all the time. So, and then that would give a lot more feedback to all the developers, and then you could scale it as much as you wanted to potentially. So that would be another thing, is that if you have an infrastructure with a virtualization environment, you can just spin up new machines and then start those with new agents, and then have those agents interacting, and then some sort of big data solution to start logging everything that you have, and then find patterns in that. You could get extraordinarily sophisticated with how this thing thinks. So, in quotes. So, yeah.
Awesome. How about coming up with artificial intelligence approaches to provide the actual data that drives?
That is something that you could potentially do. And that would be another interesting thing, is to actually go out to the internet and find correlated sets of data to names of inputs that you have. So, like this input is named something, and correlate it to something else, and then drive toward it, so on and so forth. It's all very interesting stuff.
Yeah, I use Selenium to read test data.
Yeah.
Because programmers would insert it all and miss all the stuff that was happening.
Exactly.
That were happening to it on the way in. And so then you started adding a little bit more smarts to how it generates the test data.
And currently what we're doing is we're using a CSV, and then we're matching the names of the CSV to the, and so we're already doing that.
It's
kind of cool. Yeah. Well, and that we added it in Excel, but it's pretty cool stuff. Yeah, it's fun. Yeah. But thank you everyone for coming to the talk.
So where are you located?
We're